I actually want to introduce our keynote speaker. So Justin McCarthy is actually, I guess, I don't know if it counts, like a graduate of the Bloomberg portfolio. So Bloomberg is one of our sponsors. So I think congratulations for 10 days ago, you just closed on the exit of StrongDM. So,
thank you. I think I need sharing privileges.
Okay, yeah, let's switch you over. Okay, sure, good. Yeah, and so I want to maybe, while Justin sets up, share why we thought to invite Justin as the keynote. So most of today is going to be about how to make AI safe or how to use AI to make things safer. Justin, maybe, I don't know if you'll agree with this, I think he's on the opposite end of the spectrum, which is he's trying to figure out how fast can we go with AI, even if we break a few things along the way. Maybe try to minimize that a little, but he's more on the, it's an interesting experiment of just how fast could a team go.
Supposedly I am sharing, so I don't know if there's any other.
Okay, but we're seeing on the screen is the wrong one.
Oh, that's right.
This one? Would you enjoy your mic?
All right. Thank you, folks. So thank you, Leo, for the introduction. And the one thing I'll say, just a tiny bit of background here, is we are a cybersecurity company at StrongDM. So it's true that we're actually thinking about how do we go as fast as possible. But in cybersecurity, correctness is not optional. So this is actually an area where we really have been asking how fast can we go, but always the consequences are very, very clear. And so with that in mind, everything that I'm about to present, you should think of it as existing within a cybersecurity company, within a team of engineers and product managers and sales folks and that actually care a lot about getting it right, okay? All right, so this is the story of the StrongDM software factory. So this actually begins, if we can advance here. All right, so this begins on Twitter, which is where all AI news still takes place. And the way I expressed this, I think this was way back in May of 25, is really a process that I went through personally after the initial sort of world tilted on its axis with the launch of ChatGPT. Essentially, this world of possibility unfurled in all of our minds, right? Like what could become of this new power? Almost immediately after the availability of the API, however, I and many others experienced the harsh reality that our imaginings were not manifest in the capability of the model at that moment. Okay, so that brings us up to essentially the spring of 23 here, okay? So, and the way I phrased it was, gosh, the models were not ready for multi-step agentic flows. Okay, and the way you would experience that was essentially compounding of error. Okay, so this is something that if you tried back then, or if you try with a dumber model, the list files in the directory, attempt to edit the file, all the normal things that you would expect if you were, for example, going to try to really prosecute any task, but specifically coding, engineering, any kind of cybersecurity task, that sequence was just going to degrade, and we all know the reasons for that. Okay, and then personally. I was left in that state until October of 24. So October of 24, Anthropic released a subtle revision to 3.5, and it just turned out that revision, for my purposes, caused really everything to go from never working to sometimes working, okay? And the difference between never and sometimes turned out to be huge, okay? So that captivated all of my attention, and as you can see here, like I've had a difficulty containing the top of my brain since then, okay? And obviously that goes on until this day, okay? Because what we've seen since is we've seen a series of models that are getting better and better and better at following instructions, calling tools reliably. Obviously context is expanding, obviously the price is coming down, obviously the latency is coming down, right? So in every dimension that I care about in the application of these models, it's getting more, better, faster, more capable all the time, okay? So with that initial condition, essentially, what's possible? okay? And what we're gonna talk about here is a few of the implications that I've experienced over the last 9 months or so, and what that might mean for the rest of us and the rest of all of us. Okay, so just one more journey back in time. This is what it looks like for a CTO as salesperson. This is what a CTO as sales looks like in the year 2024. You know, the poor guy committing some stuff, but not a lot of stuff. You know, 666 commits, that's still pretty good if your job is primarily sales. A year later, without really thinking about it, that number here went up by a factor of 10. So there's an order of magnitude increase in activity. And this is like subconscious. This is without me noticing, right? And this is all in the era really before the current moment of realizing that throughput has spiked. So throughput was spiking for me personally, even though I wasn't aware of it. And then obviously in this year, you know, now that the zeitgeist, now that everybody realizes stuff is working, I would say the trend continues. So I've clocked more than a third of my contributions last year already in the first month of this year, essentially, right? And this actually, a huge part of this began back in July in Menlo Park when the three of us unboxed some new laptops and really carved out a dedicated AI team, okay? So that dedicated AI team, on the first day that we got together, we wrote a bunch of use cases and missions and so forth, but among these, there was actually the most important one turned out to be, really in the first hour of that first day, we wrote this on the wall. And so we were committing in July of this year, we were committing to not write a line of code, okay? I think there are many folks right now that, again, the zeitgeist would agree that it may be possible to not write a line of code. That was not where the average sentiment was in July, okay? So in some ways, we had a little bit of a preview of the future by committing to this early, okay? And if you had quizzed me on that day, like what are some of the implications of writing this down, I wouldn't have been able to unfurl some of those implications immediately and explain it. I can now, and actually the first thing that we realized almost immediately after committing to this was if you didn't write it, there's just no way to review it without becoming the bottleneck. Okay? So you can absolutely have an higher throughput, but you can't if you review the code. Okay? And that's why almost immediately we expanded the principle of not writing code to not reading code. Okay? And it became very, very important to us, religiously important, to not review the code and not read the code. Okay? And when you combine these two, but you still absolutely have to achieve correctness, you have to achieve happy, satisfied customers. It turns out you can get all of these properties, but you need to invert, re-architect, refigure all sorts of expectations about how you would achieve that. And really, that's sort of the rest of the ideas that I'm going to share with you today. Okay. Part of this, I will say, comes through this repeated pattern in us tool users, right? I guess chimpanzees a little bit use tools, and otters kind of use tools, but we can agree that we're like the main tool users, right? So, or we were. But we have a history of building tools for understanding, okay? There's a complex problem, there's a subtle problem, there's a problem that's microscopic or macroscopic, and we can't see it and perceive it with our normal eyes and ears and touch. We need to build tools. This is a moment where building tools to help us see what's happening in the AI is a recurring theme, and we're gonna call back to this a few times. I will say though that the name of this talk is Software Factory. Like maybe it should be a software garden. I'm not sure, but I think software factory, for better or worse, is just the term of art that's sort of been established at this point. But really, every piece that you're making inside of a software factory, it really does begin with this thing that we variously call seed or an intent. It is really just a beginning of an expression of something that you want. And historically, if you go out there in the city and you find someone and their job title on their badge says product manager, that product manager, you might be able to interview them about what a PRD is, like this, this acronym that they're familiar with. So you might be able to engage in a little discussion on a PRD, and you'd hear various descriptions of it. And I think all of us are familiar with, maybe what one might look like. You definitely don't need those anymore. You don't need a whole bunch of Figma anymore. You just definitely don't need any of that. You need just a sentence or a sketch or a napkin, a little napkin sketch, or just really a blurt of any utterance. Because what you're doing with the seed is you're just setting forth in some direction, okay? And you're initiating the process, okay? You're initiating the process of encoding your intent and your desire into some small piece that is subsequently going to be nurtured and germinated and ultimately amplified by the rest of the factory process, okay? So we start with a seed, and then we inflate that seed into a series of, in this case, it doesn't really matter, but call it tranches of intent, okay? Because the models live in a world of tokens that we all created. Once upon a time, we created these things called sprints in various like software methodologies. So you could totally just use sprints and the models kind of get what you're talking about. You could call it tranche, you could call it slice, you could call it piece, you could call it bucket, just call it sprints. It's fine, it doesn't really matter. None of this matters, just anything that prevents you from biting off too much to chew in one tranche, okay? Because you can't, ultimately in a commercial environment, what we want to do is we want to write at the top of the whiteboard, make more money, and then actually not decompose the problem any further and then walk away. The models aren't ready for that. So we actually have to do a little bit of problem decomposition, one step down, and then maybe 3 steps down, okay? That's kind of where the models are at right now. As capability grows, we'll have to delete levels of that intent tree, and then we really will be able to leave make more money or cure a disease at the top of the whiteboard, and hopefully then we can walk away, all right? But for now, we have to decompose the problem into a series of tranches and have it pursue the goal. Something that many folks will realize if you've spent a lot of time generating the code is that the models are very good at claiming that they've accomplished the task, very good at claiming that they have met your intent, okay? I weight all of those claims at 0, okay? I simply don't look at them, okay? There's nothing that a model can tell me that I ever believe, okay? Really the only thing you can believe, and in fact really this becomes the locus of all of our creativity and action and energy, is in that word there. It's validation. Okay? You only have what you can validate. And in fact, it's such an extreme form of this right now that I don't know how many, anyone done injection molding before? Okay, if you do injection molding without a mold, you just spew molten plastic everywhere, okay? And then you will have like a pile of molten plastic, okay? That's the code generation. Like it will just be a pile of molten plastic, okay? But if you put a mold in there and then you inject into the mold, then all of a sudden you have this plastic enclosure, okay? So the mold that you're injecting into is the validation, and it really becomes the piece, right? If you have the mold for something, you can make 1 million of them. And that is a different way of thinking for software. If you have the test suite, the validation suite, well, the implementation is implied. If you want it in Rust, if you want it in TypeScript, if you want it in, it doesn't really matter. Anything is possible and can fill into that mold, okay? It's actually the mold that becomes, again, your locus of your energy, your attention, all of your focus. This also has the convenient property of when people begin unfurling the long series of whatabouts, this is what you point to. So just complete the sentence. What about, sorry, your name is? Dustin. Okay, Dustin, what about?
X, what about this? What about the test suites? What about the customer stories? What about the site?
Yeah, okay. So all of these whatabouts, what about security? What about performance? What about durability? All of this stuff. So you just put all the whatabouts into here. And we actually have a project internally that's called What About, and then some name of a piece that we work on. You just put them all in here. And then the reports, you just print them out. Okay? What about the stresses and loads and wind loads on the bridge? Well, you print out the stresses and loads and wind loads on the bridge. You print out the report, okay? And it becomes the same, okay? So validation is where you put all your energy. Generation, I don't know, that happens overnight, who cares? One example from our world of booting up this validation process. So at the beginning, we were working on a piece where we actually had an agentic process. So this agentic process, we wanted it to exist in email, we wanted it to exist in Slack and Teams, we wanted it to exist over text messages. And again, we're a cybersecurity company specifically focused on identity and access management. And so this sequence on the left here, you could imagine a user giving some utterance, a request. You could imagine an agent responding. You could imagine this happening again over email or Slack or text messages or whatever, okay? But we wanted this to exist, and we actually didn't have examples of this to validate against, okay? So we needed to bootstrap the validation process with some synthetic imagined examples. It turns out that all of us in this room are extremely good at judging whether this seems plausible or good or bad or redundant or incorrect or has a logical sequence in it. So for example, if the agent said on it, I need email and manager, and then the user responded Jaylin, and then the next response from the agent was on it, need email and manager, we would all be able to look at that and say, like, gosh, that was redundant. You already had the answer to that. Why'd you ask that question? That's dumb, right? So we can all do that. The moment we can do something, we shouldn't do it anymore, because the models can do it too. and so this process of bootstrapping synthetic data with maybe a little bit of style curation, like maybe we put in a few tweaks on how we would rather hear you say it. I don't like the use of emojis. I do like the use of emojis. Once you set in those positive and negative examples, the models can then come in behind you and amplify that and permute that over all possible scenarios, over all possible configurations of some world state, okay? And then you can sample from that corpus and begin validating your system against it, okay? Now, this itself models an agentic process, right? We all know that these things are, stochastic, non-deterministic, however you want to say it. They're going to pursue multiple trajectories over time. So it won't be the case that you can end your CI/CD process and end your test suite and say it is Boolean correct. But what you can do, as every other engineering discipline has done, is you can sample and you can put error bars around it, okay? And so you can say, you know what, we've tried these trajectories, we tried 100,000 of them, all but one seemed plausible and good and correct, ship it, right? And you can set your shipping tolerances. It's just you have to acknowledge that, like, you acknowledge that previously you were imagining that your test process was Boolean. In fact, there were error bars you couldn't see. Just reveal the error bars, accept it, and resume shipping, okay? Once you have a corpus that you're validating against, we should not work ourselves to the bone to continue to curate that corpus, okay? We should instead utilize the system itself to begin amplifying that corpus, okay? So what that means is, again, considering the example of an agent, every time someone interacts with the agent, you can implicitly bucket that interaction into examples of a good interaction or examples of a bad interaction. And for the gray area, for the ones that are truly undecidable by, let's say, some automated process, you put those in a pile and you have the human in the loop decide. But those will become a diminishing fraction of all activity over time, right? So you can have a validation corpus that is of increasing detail, of increasing volume, for essentially a very low cost, because whatever the use and utility of your system, as long as it's recording those trajectories, it's essentially accumulating along that trajectory of what you want, okay? So this becomes obviously an important step, and it's the step that allows you to scale. It allows you to scale validation, right? So even though validation is where all of our creative energy goes, even though it's the hard part from an engineering and creativity perspective, it's a hard but tractable part, because we're amplifying the validation itself with the models. And I'm sure there's some information theoretic or philosophical snake tail eating question of the validity of this. And I don't know, I would just say try it for yourself. And the sort of empirical approach that we've taken to this is that sure seems to work, and sure seems to be hard to find examples where I can point at something obvious and the model isn't always also pointing at the exact same obvious thing, for both good and bad examples. Here's an example of a bug report. So this bug report is actually not a functionality bug. This is more of a I'm annoyed by things being slow and costly bug, okay? So I'm annoyed that the agent was over-engineered simple operations by unnecessarily invoking planning system for straightforward preference management tasks, okay? So you could imagine this bug report existing in any bug database. You can imagine an engineer or someone in QA or a product manager noticing this inadequacy, right? So there's something here, I didn't love it, it was successful, but it was just inefficient. You know what we should do? Let's have a meeting about this. We should have a meeting about, we should skip planning for single tool operations like preference updates. And we should just read that user context directly for preference retrievals instead of creating plans, okay? So this all parses for us. Like everyone in this room can read this and say, like, that's plausibly a Jira ticket 1, 2, 3, 4, right? In a closed loop system, this is no longer Jira ticket 1, 2, 3, 4. This is a transient finding that your model is observing from the trajectories of your system, and then it's remediating, right? So no human wrote this bug report, and no human responded to this bug report. The models wrote it and responded to it and fixed it. And this is like just a real example from our real software factory, right? So if this stuff is closed loop and we don't actually have to look at it, what's our job? Our job is to really just find, we use the judicial example a lot. We're just trying to be the Supreme Court and make sure that there are cases that are undecidable that are kicked up to us. But if you think of all cases like this versus the fraction that are really tricky, that are design tricky, it's just a tiny piece. It's just a tiny piece of the total volume. Okay? And that's hopeful because, yeah, there's all this stuff just cures itself. Okay, and then really, there's so many repeated patterns in here, but I would say the one that comes back again and again is for every what about, for every undecidable, we really have to, yes? Do you have, what is that, 5 minutes? Is that a 5? This is the 5-minute warning. For every undecidable, the cure is to find a way to apply more tokens, okay? So applying more tokens has to come from a whole set of diverse places, but they're out there. You can create simulations, capture a bunch of screenshots, do win-loss reports. What else do I have? Have you fed all your email in? Send a survey to a customer. There are analysts out there that analyze everything. If you have competitors, they have earning calls. Be adversarial. Read every job description. Follow people's eyes. Record all the voice conversation. Give everybody a bunch of fake prices and have them accept your proposition, right? Have you considered satellite imagery? And then just one more sort of vignette on words of encouragement for folks. We've done this before. We think it's totally normal to see transients at a billionth of a second. It's totally normal. It's just on the test bench. It's your scope. I don't know what brand of scope you all have at home, but do I have this? No, I have a different brand. But anyway, scopes, they allow you to see things that are totally superhuman in terms of time. That's normal. They don't need to cut you open anymore to see inside your body. We use a 3 Tesla magnet to see some of this stuff, and we orient all the water molecules in your body, and that's just normal. You remember when we did that? And it's normal. It's a helium-cooled superconductor, and it's normal. Cars see with lasers, they don't need to touch the tree to know that it's there. It's laser. Cars have laser eyes. This is all normal for us now. Okay, so like we can probably like write some test suites, right? Okay. The most elaborate example of this for us is called the digital twin universe. In the digital twin universe, you can read about this online. We cloned all of our integrating peer SaaS applications that we needed to prove 10,000 times an hour. It turns out Salesforce won't let you start up 100,000 customer tenants overnight just because you want to or you ask nice. Same thing with Google Drive. They won't let you create and destroy tenants and objects and users at the rate we want to. So we copied all of this. Copied sheets, no problem. You could just have this now. And the digital twin universe of all those SaaS, we always wanted it. It was simply uneconomical previously. Okay? That bit has flipped. It's different now. Okay? You can have what you want now. And really for those EEs out there, it's just this. And it's true that making sure your feedback leg is actually connected in your software and you're not deluded about that, that's hard. But once it's connected, this circuit will stabilize. Okay, how many more minutes? 3 minutes. For those of you that enjoy stable temperatures, you'll also recognize the calculus inside of a PID controller, okay? All that thing is doing is it's trying to turn a square wave into a nice, consistent temperature. Okay, so really the feeling of these systems is they can overshoot, they can undershoot if you get the specification wrong. But through compounding all of these techniques, ultimately you are going to find a way to converge these systems to a definition and a behavior that you want. Okay, our thermostats turn square wave furnaces and air conditioners into a nice, consistent temperature, and they do it through a process. Oh, I don't have demos. Hold up. How did I get the deck wrong? Okay. I think we're going to run out of time, but so I'm going to skip this. All right. I have a few more slides that we're not going to talk about. No, hold on. No, I actually do need to switch slides. One sec. Yeah, let's hear it. While I'm happy to take questions while I recover the important slide.
Testing. So I'll do one on behalf of the internet. Actually, on my behalf, so first, thank you. But on behalf of the internet, how do your colleagues in like legal, risk, finance, all those things react to shipping things in this way?
Yeah, so I think that's a really great question. Yeah, because the risk is obviously super huge, and so I think every one of us has colleagues that are involved in managing risk, and so the risk of inaction and allowing your competitors to proceed ahead of you in the market is huge.
What are you finding that's still hard?
Okay, so the part that's still hard, I would say, is getting the right tokens. So the tokens are out there. A lot of them are hidden latent variables inside of biological neural networks that are in the form of your customers. It could be in your customer's culture, but a lot of times it's in the sort of sum of some subset of your customer's brains. And you have to go to lunch with them, and you have to build trust. And you have to build trust and say, what if I sold you this pen, would you buy it if it were red? Would you buy it if it were blue? Would you buy it for $1? Would you buy it for $100? Would you buy it for $1,000? That process is still extremely manual. Getting those tokens takes a lot of effort. There's actually skill, there's EQ involved. All that stuff, those are really expensive tokens.
Great. Well, thank you, Justin. I think we should probably.
All right. So let me just skip ahead to the. All right. Anyway, all this is true. All right. There you go. Go apply more.